Pluto's trajectory has always been a subject of intrigue and concern. From the beginning, Pluto's orbit has intersected with that of another planet, which naturally raised questions. Pluto, the enigmatic and small celestial body situated in the farthest reaches of our solar system, has become a frequent topic of discussion in the field of astronomy. Recent revelations have sparked alarm, indicating a possible collision with Neptune, a scenario that has captured the attention of scientists and space enthusiasts alike. Notable figures like Neil deGrasse Tyson and Michio Kaku have voiced their worries about the potential implications of this celestial encounter. But how did Pluto's path lead to a possible collision with Neptune, and what would such an event mean for Earth? Join us as we explore the intricacies of Pluto's journey and why scientists are increasingly concerned about this cosmic anomaly. Once hailed as a full-fledged planet, Pluto underwent a significant reclassification as a dwarf planet, largely due to the erratic nature of its orbit. Despite its demotion, Pluto continues to captivate and intrigue those within the astronomical community. Recent warnings from prominent scientists, including Neil deGrasse Tyson and Michio Kaku, have suggested that Pluto's orbit might intersect with Neptune's, raising the potential risk of a collision with far-reaching consequences for our planet. Pluto's orbit around the Sun is remarkable, owing to its distinctive features. Its orbit is exceptionally lengthy, taking an astonishing 248 years to complete. Since its discovery in 1930, Pluto has not yet completed a full orbit. What makes Pluto particularly fascinating is the highly elliptical shape of its orbit, in stark contrast to the nearly circular orbits of the major planets. Additionally, Pluto's orbit is tilted at an angle of 17 degrees relative to the ecliptic plane, resulting in a steeper incline than that of the other planets. This combination of inclination and the elongated orbit adds complexity to its movement. A particularly striking feature of Pluto's orbit is its recurring intersection with Neptune's orbit every 20 years. During these periods, Pluto's path brings it closer to the Sun than Neptune, which challenges the expected relative positions of the two planets within the solar system. Further examination reveals that Pluto's orbit is far from a perfect circle. Instead, it follows an elliptical, oval-like trajectory, meaning its distance from the Sun fluctuates dramatically throughout its orbit. At its closest point, Pluto reaches about 30 astronomical units from the Sun, but at its farthest, it stretches to over 49 astronomical units, nearly double the distance of Neptune from the Sun. Additionally, Pluto's orbit is tilted at an angle relative to the paths of other planets, adding another layer of complexity to its relationship with Neptune. This inclination plays a crucial role in how Pluto and Neptune interact. When their orbits cross paths, their gravitational forces interact, gradually altering their trajectories. This interaction highlights the interconnected nature of the solar system, where the gravitational influence of one body can affect the motion of another. With advancements in observational technology, astronomers have been able to track Pluto's movement with greater precision, leading to a clearer understanding of its orbit and its potential effects on the overall stability of the outer solar system. While the likelihood of a direct collision between Pluto and Neptune is low, the possibility is still being carefully monitored. Scientists are concerned because the consequences of such a collision could be catastrophic. Despite its small size and distant location, Pluto remains an object of great fascination for both scientists and space enthusiasts. A crucial question arises, however: why hasn't Pluto collided with Neptune already? The answer lies in the gravitational influence of other planets. Since Pluto's discovery, astronomers have been attempting to decipher its path. Unlike most planets, which maintain relatively consistent orbits along the ecliptic plane, Pluto's orbit stands out due to its steep angle and elliptical shape. The mystery deepened when it became apparent that Pluto's orbit crosses Neptune's, presenting a potential danger. Despite this, Pluto's orbit remains surprisingly stable, demonstrating the intricate mechanics that govern the movements of celestial bodies. Studying the interactions between Pluto, Neptune, and the Sun presents a considerable challenge for astronomers. Predicting their movements requires an in-depth understanding of how they influence each other's trajectories. To navigate this complexity, scientists employ various concepts, such as ASMU libration, latitude libration, and VSOP and Steves-Kaplan isolation, to decipher this cosmic puzzle. For example, ASMU libration plays a key role in maintaining the stability of planetary orbits. When Pluto crosses Neptune's path, it remains at least 90 degrees away from Neptune, preventing a direct collision. Latitude libration ensures that when Pluto nears Neptune or any large planets, it is positioned above their path, reducing the chances of a crash. The VSOP oscillation, named after scientists von Zipper, Steves, and Kaplan, explains why Pluto's orbit appears unusual yet remains stable over time. Even though space seems chaotic, there are underlying patterns that maintain order and prevent Pluto from colliding with Neptune or drastically altering its orbit. The concept of orbital chaos, which refers to the sensitivity of a celestial body's trajectory to its starting position, is clearly evident in Pluto's orbit. Even minor variations in Pluto's position or velocity can have significant effects over long periods. Scientists use advanced computer simulations to model Pluto's interactions with other bodies in space, like Neptune, and to explore the consequences of even the smallest changes in its trajectory. In the late 1980s, these simulations revealed an interesting finding. Despite Pluto's orbit appearing stable, it can still behave unpredictably. A tiny shift in Pluto's initial position or speed could cause significant changes over time. However, even with these uncertainties, Pluto's orbit remains stable over billions of years, suggesting that despite its chaotic appearance, it follows an underlying order. The unpredictability of planetary orbits, like Pluto's, makes it difficult to accurately predict long-term changes. These models require highly precise initial conditions because even the smallest data errors can lead to vastly different outcomes, making accurate predictions exceedingly difficult. Understanding Pluto's orbit is crucial, especially when considering the potential for a future collision with Neptune. This knowledge helps astronomers gain a deeper understanding of the solar system's mechanics. Pluto's orbit serves as a prime example of how seemingly chaotic paths can eventually achieve balance, guided by the forces of gravity and motion. It is essential to continue observing and studying these celestial mechanics in order to better understand our place in the universe. Pluto's orbit perfectly illustrates the unpredictable nature of space. Its unusual, oval-shaped path leads to unpredictable encounters with Neptune, making it difficult to forecast the long-term dynamics of the system. However, gravitational forces play a vital role in preventing Pluto and Neptune from colliding. Gravity, which attracts objects to each other, ensures that despite the intersecting orbits, the two bodies typically stay apart. The possibility of a collision between Pluto and Neptune, though unlikely, would be a monumental event with significant consequences. Such an event would radically alter our understanding of the solar system. Although space exploration has made considerable advances, Pluto's orbit remains a reminder of the many unknowns that still exist in the cosmos. Scientists continue to monitor Pluto's trajectory to better comprehend how larger planets influence its motion. This knowledge is critical for understanding the intricate relationships between celestial bodies and how their movements can impact each other. Notably, some of the world's leading scientists, such as Neil deGrasse Tyson, have speculated that Pluto could one day collide with Neptune. Tyson, a prominent astrophysicist, sees Pluto's reclassification as a dwarf planet as a necessary step, acknowledging the importance of further exploration and study. He believes that Pluto's strange orbit highlights the fact that much remains to be discovered about space and the forces that shape it. According to Tyson, the mysteries of space are what makes studying it so captivating, and he encourages others to delve into the fascinating complexities of celestial mechanics. Along with other experts, Tyson expresses concern about the potential dangers posed by Pluto's unusual orbit. Should a collision between Pluto and Neptune occur, it could lead to catastrophic consequences for our solar system. The energy released from such an event would be immense, and the debris scattered throughout space could have far-reaching effects, possibly even impacting other planets and moons. Neptune itself would be affected, and its orbit could change, further complicating the dynamics of the outer solar system. Renowned theoretical physicist Michio Kaku, known for his contributions to string theory, also offers valuable insights into space exploration. Kaku believes that studying phenomena like Pluto's orbit is essential for understanding the broader principles of celestial mechanics and theoretical physics. He suggests that examining Pluto's interactions with Neptune can help scientists ensure the safety of future space missions. Kaku also emphasizes the importance of understanding gravitational forces in space exploration, as they could significantly shape how we explore distant worlds. His work in string theory, which seeks to explain the fundamental forces of the universe, aligns with his interest in Pluto's orbit. A collision between Pluto and Neptune could provide crucial data that would contribute to our understanding of gravity and spacetime, areas central to string theory. Although such an event would have minimal direct impact on Earth, it could offer a unique opportunity to study the behavior of fundamental forces under extreme conditions. As space exploration continues, the unpredictability of planetary interactions becomes increasingly evident. The study of celestial dynamics, such as the intricate gravitational relationship between Pluto and Neptune, offers valuable insights into the fundamental laws of the universe. By continuing to monitor and study these phenomena, we move closer to unraveling the complex nature of the cosmos. The gravitational dance between Pluto and Neptune highlights how even distant planets can exert influence over one another. These celestial bodies exert gravitational forces that, over long periods, can subtly but significantly shape their orbits. While a direct collision remains improbable, the possibility cannot be ruled out entirely, which keeps scientists and astronomers on alert. Understanding these forces could one day allow us to predict and mitigate the risks posed by such cosmic events. One fascinating aspect of planetary motion is how seemingly random or chaotic interactions can give rise to stable, predictable patterns. This is especially true in the case of Pluto, whose orbit might seem erratic but is actually governed by precise gravitational forces. These forces help prevent Pluto from colliding with Neptune, despite the apparent overlap in their paths. The delicate balance between the gravitational pull of other planets and Pluto's orbit keeps the dwarf planet on a steady, albeit complex, course. Understanding this intricate relationship is key to advancing our knowledge of the broader solar system. As scientists continue to investigate Pluto's orbit, they also turn their attention to other areas of space exploration. For instance, studying systems like TRAPPIST-1, which contains multiple Earth-sized planets, helps astronomers understand how gravitational forces between planets can lead to orbital resonances. In some cases, these forces can destabilize a planet's path, leading to instability. Though the TRAPPIST-1 system is not experiencing any collisions currently, scientists continue to monitor planetary movements within these crowded environments to better understand potential risks and their evolution over time. Meanwhile, astronomers are also focused on understanding the behavior of rogue planets, which travel through space without being bound to any star. As our exploration of space deepens, the study of celestial bodies like Pluto and the TRAPPIST-1 system becomes increasingly crucial for expanding our knowledge of cosmic mechanics. The study of rogue planets, which do not orbit stars, offers yet another layer of complexity to our understanding of planetary motion. These planets, drifting through space without gravitational ties to any star, provide an interesting challenge for astronomers trying to decipher the many different ways planets can behave and evolve in the vastness of space. Their unpredictable trajectories can introduce new variables into the already complex dynamics of celestial mechanics, and understanding them could offer crucial insights into the formation and movement of planets in systems outside of our own solar system. The unpredictable nature of Pluto's orbit provides valuable lessons in how celestial bodies can follow seemingly random paths, but still adhere to deep, underlying patterns dictated by gravitational forces. Despite its odd, elliptical orbit and tilted trajectory, Pluto remains a testament to the accuracy with which gravity governs planetary motion. By studying such anomalies, scientists are uncovering the governing laws of orbital dynamics and applying them to other celestial phenomena, helping to predict and explain the behavior of distant objects in space. Although the chance of a Pluto-Neptune collision is small, the possibility itself keeps astronomers on high alert. Understanding the gravitational relationship between these two distant bodies and their paths is important for ensuring that future space missions and explorations do not unexpectedly encounter any obstacles. Even though a collision between Pluto and Neptune would likely have minimal direct consequences on Earth, it would still offer a profound opportunity for scientists to observe the workings of gravity and spacetime under extreme conditions, potentially offering new data to support ongoing studies in astrophysics. In addition to Pluto's unusual path, the study of other similar cosmic anomalies continues to provide insight into the many mysteries of the universe. As our technology and observational methods improve, scientists are able to refine their models of planetary and orbital behavior. This ongoing research is essential for understanding the intricate dynamics of the solar system and beyond, as each discovery contributes to a more complete picture of the universe's behavior. In particular, understanding how gravitational forces influence the movement of celestial bodies provides critical knowledge for planning future space missions, especially those venturing to distant exoplanet systems or into the outer reaches of our own solar system. One significant aspect of Pluto's orbit is its resonance with Neptune, a relationship that plays a key role in ensuring the stability of the two bodies' orbits. Although their paths cross every 20 years, the gravitational forces between Pluto and Neptune are in sync in such a way that they do not collide. The careful balance between their movements is a testament to the precision with which the laws of physics operate, even in the most distant regions of the solar system. This resonance helps prevent any potential crashes, ensuring that the planets continue to coexist without significantly altering one another's paths. This intricate dance between Pluto and Neptune serves as a reminder of the cosmic order that underpins even the most chaotic-sounding orbital mechanics. While Pluto's orbit is far from typical, it is a prime example of how the universe operates with a level of precision and order that is not immediately apparent. Despite its irregularity, the planet's path is influenced by the gravitational forces of neighboring bodies, which help maintain its stability. Through continued observation and study, astronomers continue to gain insights into how even the most seemingly unpredictable objects in space can be part of a larger, more organized system. This knowledge allows scientists to better predict the future behavior of objects in our solar system and beyond. As technology advances and our ability to study celestial bodies improves, we can expect to learn even more about the forces at work in space. The study of Pluto's orbit, along with other objects like rogue planets and distant star systems, will continue to be crucial for understanding the vast, complex universe. Through these studies, scientists will not only better understand the mechanics of planetary motion, but also learn more about the fundamental forces that shape the cosmos. The ongoing exploration of Pluto, Neptune, and other celestial phenomena helps to further our understanding of space and our place within it. The unpredictability of planetary interactions, like the potential collision between Pluto and Neptune, emphasizes the dynamic nature of space. As astronomers gather more data and refine their understanding of planetary motion, they gain a clearer picture of the forces at play. However, there is still much to learn about how these forces influence celestial objects and how they might change over time. The study of Pluto's orbit, with its complexity and irregularities, provides a rich field for exploration and offers valuable lessons that extend beyond just this particular system. In the years to come, continued advancements in space observation and exploration will no doubt yield even more insights into the behavior of planets like Pluto and Neptune, and perhaps even uncover new phenomena that challenge our current understanding of the universe. Understanding the interactions between planets, including the delicate gravitational dance between Pluto and Neptune, will not only help us predict their movements but also improve our ability to safely explore the cosmos. These discoveries will likely shape the future of space exploration and deepen our comprehension of the universe's vast and complex nature.